It's a very busy time for local farmers. We're told the corn and soybeans are looking great, but as Dan Cummins reports, it's up to Mother Nature from here.
Hidden beneath the endless rows of corn and soybeans that dominate today's Midwest are the ancient remains of one of Earth's most magnificent ecosystems. Here, where industrial agriculture has created a green desert of monocultures, there once stretched the tallgrass prairie, a sea of grass so vast and alien that early European settlers called it prairie madness, because the sheer scale of the treeless expanse drove many to psychological breakdown.
I came out to the Les Hills to find out what one group is doing to both restore and preserve Iowa's native prairie.
This was no empty wasteland. The American prairie was one of the richest ecosystems on Earth, supporting massive herds of bison, countless bird species, and indigenous peoples who had perfected sophisticated fire management and ecological stewardship techniques over thousands of years. The deep black soil that made the Midwest America's breadbasket was created by this prairie ecosystem.
So I spend a lot of time harvesting seeds in the field during the summer and fall.
Thousands of years of plant and animal decomposition depositing massive carbon stores into the ground. But in less than 100 years, European settlers accomplished one of history's largest terraforming projects, plowing up 99% of the tallgrass prairie and fundamentally rewiring the continent's climate, hydrology, and carbon cycles.
It's been 30 years since bison were reintroduced to the tallgrass prairie, a once thriving ecosystem that had been dead for more than 100 years.
Today, the tallgrass prairie clings to just 1% of its former range, and we're still losing 1 million acres of remaining grasslands every year, the climate equivalent of adding 11 million cars to the roads annually. Yet scattered across the Midwest, a quiet revolution is taking place. Farmers, homeowners, and conservationists are rediscovering that these seemingly worthless patches of agricultural land can be transformed back into thriving prairie ecosystems using techniques that indigenous peoples perfected millennia ago. And the results are nothing short of extraordinary. Stay until the end, because today, you're going to discover how ancient fire management and ecological restoration techniques are bringing back America's lost prairie 1 acre at a time, and why this could be the key to solving our climate crisis while feeding the world. Welcome to Forgotten Lands. The transformation begins with understanding what we lost. When David Reed bought 38 acres of former farmland in suburban Dexter, Michigan in the 1990s, it was slowly succumbing to invasive shrubs and weeds. The property sat just off Interstate 94, surrounded by suburban development, with degraded soil that could barely support the struggling vegetation that had taken over after farming ceased. But Red, a big guy standing 6'2", had a vision that seemed impossible to his neighbors. He wanted to restore 11 acres of this abandoned farmland back to the native tallgrass prairie that had covered this region for thousands of years before European settlement. When he retired in 2003, he set about one of the most challenging ecological restoration projects imaginable. What Red discovered was that prairie restoration is not for wimps. It requires an intricate understanding of grassland ecology, careful timing of multiple interventions, and years of intensive labor. He began by studying the complex relationships between the hundreds of native plant species that once thrived in Michigan's prairies. He learned about the critical role of fire in maintaining these ecosystems. Most importantly, he discovered that successful prairie restoration requires working with natural processes rather than against them. The first technique is soil preparation and invasive species control. Unlike simply planting a garden, prairie restoration requires completely resetting the ecological clock. Red and other prairie restorers use a sophisticated approach that begins with eliminating invasive species that have colonized former agricultural land. Some farmers plant genetically modified Roundup-ready crops specifically so they can use herbicides to clear the soil of invasive seeds before beginning prairie restoration. This preparation phase can take multiple growing seasons. The goal is to create a blank slate where native prairie plants can establish without competition from aggressive invasive species like autumn olive, multiflora rose, and non-native grasses that dominate disturbed agricultural land. The process requires careful timing. Herbicide applications must happen at specific points in invasive plants' growth cycles to be most effective. Reed spent years looping and herbiciding weedy brush, putting in 20 hours a week or more during peak seasons. He brought in heavy equipment to drill, till, and prepare the soil. The work was physically demanding and technically challenging, requiring expertise in plant identification, soil science, and ecological timing that most people don't possess. If you're amazed by this transformation so far, comment Prairie below and let me know what you think could happen if these techniques were applied to abandoned farmland across the Midwest. The second technique is strategic seeding and plant establishment. Prairie restoration isn't simply scattering wildflower seeds and hoping for the best. It requires understanding the complex relationships between dozens or even hundreds of native plant species, each with specific soil, moisture, and light requirements. Successful prairie restoration uses seed mixes that include grasses, wildflowers, and other plants in carefully calculated proportions. Deep-rooted prairie grasses like big bluestem and switchgrass form the foundation of the ecosystem, with their roots extending 10 feet or more into the soil. These grasses create the structure that supports shorter wildflowers and forbs. The seeding process itself requires specialized equipment. Prairie seeds vary enormously in size and shape, from tiny seeds that are almost dust-like to large seeds with complex shapes that make them difficult to distribute evenly. Professional prairie restoration often uses no-till drills that can handle this diversity of seed types and place them at appropriate depths. Timing is critical. Most prairie seeding happens in late fall or early spring, when soil moisture and temperature conditions favor germination. The first year after seeding, the new prairie looks like a disaster, mostly weeds with scattered small prairie plants that seem to be losing the battle. But prairie plants are investing their energy in developing massive root systems rather than above-ground growth. By the second and third years, the prairie plants begin to dominate. Their deep roots give them access to water and nutrients that shallow-rooted weeds can't reach. The result is a dramatic transformation as native grasses and wildflowers take over, and invasive species are crowded out. The third technique is prescribed fire management. This is perhaps the most critical and misunderstood aspect of prairie restoration. For thousands of years, indigenous peoples used controlled burns to maintain prairie ecosystems, and modern restoration requires reintroducing fire to the landscape. Prairie plants evolved with fire. Their growing points are at or below ground level, protected from flames, while their extensive root systems store energy that allows rapid regrowth after burning. Trees and shrubs, by contrast, are damaged or killed by fire, which is why prairies remained treeless despite adequate rainfall to support forests. Reed and other prairie restorers conduct prescribed burns every few years, carefully planned and executed under specific weather conditions. The burns remove accumulated dead plant material, return nutrients to the soil, and stimulate new growth. They also eliminate tree seedlings and invasive plants that haven't adapted to fire. The transformation that results from proper fire management is dramatic. Within weeks of a prescribed burn, the prairie explodes with new growth. Native plants that seemed dormant suddenly produce vigorous shoots. Wildflowers bloom more abundantly. The entire ecosystem responds as if awakened from sleep. But here's what makes this story truly extraordinary. These farmers and restorers aren't inventing new techniques. They're rediscovering and applying ecological management methods that indigenous peoples had perfected over thousands of years of sustainable land stewardship. The Lakota, Dakota, and Nakota peoples of the Great Plains developed sophisticated fire management systems that maintained millions of acres of productive prairie while supporting massive bison herds. They understood that fire was not destructive but regenerative, and they used controlled burns to create the mosaic of habitats that supported incredible biodiversity. The Osage people perfected techniques for using fire to maintain oak savannas and prairie edges, creating productive hunting grounds and gathering areas. The Potawatomi developed extensive knowledge of prairie plants and their uses, managing ecosystems that provided food, medicine, and materials while maintaining ecological integrity. These indigenous fire management systems were based on careful observation of natural cycles and deep understanding of plant and animal relationships. They knew when to burn different areas, how to create fire breaks, and how to use wind and weather patterns to control fire behavior. Most importantly, they understood that fire was an essential tool for maintaining the health and productivity of prairie ecosystems. If this story is inspiring you to think differently about what's possible with abandoned agricultural land, hit that like button and subscribe to Forgotten Lands for more stories of ancient wisdom solving modern problems. The results of prairie restoration are nothing short of miraculous. On Reed's property in Michigan, the transformation has been complete. Where once there was degraded farmland struggling to support invasive weeds, there is now a thriving prairie ecosystem that supports an explosion of wildlife. The shimmering trill of thousands of insects nearly drowns out the traffic noise from nearby Interstate 94. Coyotes, foxes, deer, raccoons, skunks, possums, rabbits, owls, hawks, and numerous other birds are regular visitors. During one summer, Red witnessed an explosion of enormous dragonflies that would cruise just above the grasses, turning around and coming back when they reached the edge of the prairie, as if they knew they belonged in this specific ecosystem. The economic benefits are equally impressive. While the initial investment in prairie restoration ranges from $2,200 to $5,000 per acre, the long-term costs are dramatically lower than maintaining conventional landscapes. Prairie requires no fertilizer, less water than lawn, and minimal mowing once established. After the first few years, maintenance consists primarily of occasional prescribed burns and spot treatment of invasive species. The environmental benefits extend far beyond individual properties. Prairie restoration is one of the most effective climate change mitigation strategies available. Earth's grassland soils contain 1/3 of the planet's terrestrial carbon, more than the total released by human activity since the Industrial Revolution. A 2020 Nature study found that restoring just 15% of the world's plowed grasslands could absorb nearly 1/3 of the carbon dioxide humans have added to the atmosphere since the 1800s. The movement is growing rapidly. The Prairie Enthusiasts, a grassroots organization focused on prairie restoration, has grown from 5 chapters a decade ago to 11 chapters today, with 1,200 members across Wisconsin, Illinois, and Minnesota. Members band together to swap work on one another's properties, creating a modern version of the barn raisings that once characterized rural communities. Professional prairie restoration services are expanding to meet growing demand. Neil Dibble, president of Prairie Nursery in Wisconsin and a leading advocate of native plant gardening, reports completing projects exceeding $100,000 as landowners recognize the value of large-scale prairie restoration. The scalability of prairie restoration is remarkable. The Midwest contains millions of acres of marginal agricultural land that could be converted to prairie without affecting food production. Much of this land is economically unviable for farming, but perfect for prairie restoration. Federal conservation programs like the Conservation Reserve Program already provide financial incentives for farmers to take environmentally sensitive land out of production. The timing couldn't be better. As concerns about climate change intensify and the limitations of industrial agriculture become apparent, prairie restoration offers a solution that addresses multiple challenges simultaneously. It sequesters carbon, supports biodiversity, improves water quality, reduces erosion, and creates resilient landscapes that can withstand extreme weather events. What's more, prairie restoration demonstrates that agriculture doesn't have to be extractive and destructive. When farmers and landowners apply indigenous wisdom about working with natural processes, they can create systems that actually improve the land while providing economic and environmental benefits. The transformation also reveals something profound about the relationship between humans and the landscape. As Red explains, we wanted to sit on our back porch and watch grass swaying in the wind. This simple desire to reconnect with natural processes has created an ecosystem that supports hundreds of species and stores massive amounts of carbon. The broader implications are staggering. If even a fraction of the Midwest's marginal agricultural land were converted to prairie, the region could become a massive carbon sink while supporting biodiversity and providing sustainable economic opportunities for rural communities. The techniques are proven, the benefits are clear, and the need is urgent. Perhaps most importantly, prairie restoration shows that seemingly hopeless environmental situations can be reversed with the right knowledge and commitment. Every abandoned farm field represents not just a problem to be solved, but an opportunity to recreate one of Earth's most magnificent ecosystems. As one prairie restoration expert explains, nature does not like simplicity. Nature likes complexity, and if we had a more complex farm system, it would be better for everyone. This insight captures the essence of what makes prairie restoration so powerful and relevant today. Today, as industrial agriculture faces increasing challenges from climate change, soil degradation, and economic pressures, the story of prairie restoration offers more than just hope. It offers a proven blueprint for transformation that has been tested over thousands of years. It shows that even the most challenging ecological restoration can be accomplished using techniques that indigenous peoples developed through generations of careful observation and experimentation. The question isn't whether these techniques work. Restored prairies across the Midwest stand as living proof that they do. The question is whether we'll have the wisdom to learn from both indigenous knowledge and modern examples, and the courage to implement these solutions at the scale our climate crisis demands. Because hidden beneath every abandoned farm field in the Midwest are the ancient remains of a lost American prairie, waiting to be brought back to life.